Okay. We use indirect measurement when we want to measure something that's too difficult to measure directly. And by way of example, the activity that I had planned and that we still may do would be to calculate the height of this building. Yeah. No, we're not doing this. So the idea would be to calculate the height of this building. Now, of course, if we had a really big ladder or a crane, we could just take some kind of tape measuring device and measure the height of the building. But since, to my knowledge, nobody carries around a crane or a giant ladder around them in their pocket, we have to come up with another way to do it. And what we're going to do is we're going to create a similar figure, a similar triangle. And then when we use the measurements of what we do know to calculate the measurement of what we don't know. Okay? So if you have your textbook, or in the textbook is a picture of a kid who wants to measure the height of a giant rock that he wants to climb. So what we get is we're going to get something that looks like this. So here's what we're told in the problem. We're told that that this kid wants to measure. He wants to climb the rock here. He wants to climb the rock. He wants to know how tall the rock is. Since we don't know how tall the rock is, we call it X. Now we're told other pieces of information. We are told that he walks backwards and places a mirror on the ground where he can see the top of the hill, or the rock. And that is 34 feet away. So this is a mirror. So what happens is you walk away from the figure that you want to measure. You put a mirror on the ground, you look through the mirror, and you look up, and you can see the top of the object. We're told that he is 5 feet. I'm sorry, he's 5.5 feet tall. Six. And that he is standing 6 feet away from the mirror. So here's so what we know is that we have that these are both right angles, and we know that these angles are vertical angles. So we know that the triangles are similar using the angle-angle similarity postulate. So once we know that, we can set up a proportion. So again, there's two ways to do this. You can either compare the corresponding sides, or you can compare the two sides on one triangle with the corresponding sides on the other triangle. So I'm going to compare corresponding sides. So I'm going to set up that 5.5, that the size of the kid corresponds with the size of the rock. So it's 5.5 is to X. And again, what I did is I'm doing little over big, the little triangle over the big triangle. So the corresponding side is 6 and 34. So now I cross multiply. I get 6x is equal to 34 times 5.5. So 34 times 5 is 170. 187. get that 6x equals 187. Divide both sides by 6. You get that x is equal to 32, about 32.3, 32.33. No, 31.2, sorry. Because it's 6 and not 30. I couldn't do it in my hand. It's actually, well,